Problem 7.17. So suppose we have a PDF of a continuous random variable x that is given by this. Okay, and the question is to find the PDF of x cubed and plot the PDFs of x and y. So here I should say that y equals to y is defined to be x cubed. So find the PDF of x and y that indicate the area under which and the curve such that they represent these two probabilities. Okay, so let's see how to proceed with that. So because x can only take a value between 0 and 2, so that's the support of the PDF. Okay? So x can only be between 0 and 2, so the x cubed can only be between 0 and 8. So that is one thing that we know. And on the other hand, we see that y equals to, let's say, I define the function u of x to be x cubed. So that essentially means the y is just equal to u of x. So the u of x is defined as the cubic function. Then the inverse of u. Remember that the cubic function is monotone, right? It's strictly increasing in the positive side of the real numbers. So since y is between 0 and 8, so that means the u must be monotone, right? Strictly monotone, strictly increasing. So the inverse exists, and the inverse of u will be just the cubic root. So we call the inverse of u to w, and that's just the cubic root. Then we can use the formula we given in class. The PDF of y is just the PDF of x evaluated as the point w of y times the absolute value of the w prime at y. So here f is this guy. Okay? So that's the f function. We need to make a composition of this f and this w. So it's half of x, but x becomes this guy, right? So x equals to w of y. So w of y is this, so just to put in here. And then this guy, we take the derivative of this with respect to y. We'll get 1/3 times y to the power negative 2/3. So that's this guy, okay? And then combining the two, we'll get this. And remember that this is for y that's between 0 and 8. And the probability will be 0 outside of this interval. So in summary, we just have that. Okay, so now if we plot the picture, so remember that this is what the PDF of x is. It's just sorry, I plotted it wrong, right? It should be half x. So it's not that. Should be just here to here, which is 1. And then if I'm interested in the probability that x is between 1/2 and 1, then that just means the area under the curve that is also between the point x 1/2 and 1. So that's the area. Okay, so that's this is the probability density function of x. So for the probability density function of y, we know that it's just this guy, right? It's just over 6 times y to the cubic root. Okay, the cubic root of y. So that's when y equals to 8, this number becomes 2, and this is 1 over 12. So that's the curve. So this guy is the curve of the probability density function of y. The probability that y falls into the interval 1 over 8, and the 1 is just the area. So just plot these 2 points and draw the area that's under the curve. So that is probability.